Our planet is surrounded by a magnetic field and also by an electric field. For over a century, electric power has been generated using magnetic fields. But now, using our own proprietary methods, Triton Technologies generates electric power using electric fields. Well, what we usually call generators manipulate magnetic fields when they are rotated, and electric power is produced. These magnetic fields need large amounts of iron and copper. But the Triton generators use no magnetic fields, and they don't need iron or copper. Ordinary generators with all their iron and copper must be turned rapidly to generate electric power. That's fine if you're driving them with diesel engines or the swift water rushing from the base of a dam. But if you want to harness the ocean or the slow water from some 2-mile-per-hour river, you're going to have to use something very different. Generators and their kissing cousins, electric motors, are so common, and they've been around for so long, that many people think they must be the only way to generate electricity. But the solar cell in your calculator or the thermocouple in your hot water heater use different means, and anyone who's ever been near an electrical storm can tell you that nature generates fantastic levels of electric power and using a different means yet. Now, I would like to show you a little bit about the basic principles behind the wind, river, and ocean generators. The device you see here is a rotary machine and constructed quite differently than the ocean power, but they both take advantage of the same basic principle. Look at this machine, which is a simple demonstration of the principle, connected to this oscilloscope. As with an ordinary generator, which is filled with lots of iron and copper wire, I rotate the shaft of this machine and electricity comes out. Beyond that, it's hard to find any similarity. This particular form of the machine is called the LRP, which stands for lateral rotary peristaltic. Peristaltic is from a Greek word meaning successive waves. This machine traps electric charge, the stuff that accounts for the fireworks and storm clouds, and successively squeezes this stuff back and forth to generate alternating current electricity. You see the result on the scope. Notice that as I turn the shaft of the LRP, I can produce plenty of voltage, about 100 volts in this case, even when the shaft is turning slowly. This is quite different from ordinary generators. Perhaps more important is the fact that I can turn it so slowly and still produce the 60 hertz power we need. I have sometimes been asked, if this is such a good idea, why hasn't it been done before now? Well, ordinary generators have been around for more than a century and they do work, and questions about the environment and about conservation have only been raised recently. And so only recently have we looked for new ways of generating electric power. Most importantly, the materials to make the Triton generators practical and cost-effective have only recently been developed. Let me give you an example. This little box you see is actually a fan, but it contains no motor in the usual sense. You can see right through it. Special plastics enable the line power to make these blades wave and generate a breeze without any iron or copper. Now, when I connect the fan to the oscilloscope and I wiggle the blades, you can see it generates electricity. This wasn't possible a few years ago. And our advanced designs of these new Triton generators would have been impractical just a few years ago, because without modern materials, I would not have been able to produce the innovations that I have. We have had professional engineers and scientists examine Triton machines and certify them. Our patent procedures are progressing, and we have even had financial appraisals done on the impact that such technologies are expected to have on the huge energy industry. This appraisal is inherently conservative because it does not account for the new sources of power which the Triton generators will utilize. Now let us consider some examples of how this technology could be applied in specific designs for the generation of electric power. A significant portion of our electricity is generated from what we call wind farms. These are huge collections of modern windmills. But as you can see, they don't operate all the time because the good wind only blows a few hours a day. There is still energy available in the not-so-good wind, but it's not cost-effective to use it. But rivers flow 24 hours a day, and moving water carries much more energy than does moving air. Now, one of the proprietary features of the LRP design will be very important to the wind farm industry. For technical reasons, only wind of a certain speed drives the blades of the wind farm generators with good efficiency. That's because the blades generally must be driven at a very constant speed, regardless of variations in the wind speed. But one of the LRP designs, very different from the river power generator, will enable the LRP to produce a constant 60 Hertz output frequency as required by the power companies, even though the blade and generator vary in speed. This can result in considerable extra output from wind farms. By replacing the generator with the LRP, but leaving the blade, the tower, the grid hookup, and the real estate unchanged, we would roughly double the electrical power produced. You can imagine the financial impact such an innovation could have in domestic and foreign wind power markets. But rivers flow 24 hours a day, and ocean currents move 24 hours a day, and ocean waves splash on the shore 24 hours a day, and moving water carries much more energy than does moving air. We are here north of San Francisco, where the Russian River empties into the Pacific Ocean. The flow of this little river is only about 2 miles per hour. But water moving at 2 miles per hour carries the same energy as a very stiff 18 mile per hour wind at the wind farms. You've seen now a demonstration of the principle of the LRP rotary generator. You've seen that the shaft can be turned very slowly and still produce 60 cycle power. So imagine, if you will, one of these generators mounted on a barge, anchored in a river, so that's stationary, with a special blade underwater, slowly turning the generator, producing 60 cycle power, which is fed by ordinary submarine cable to the shore and then distributed as necessary. Now, the barge itself would be small compared to the river, so it would not interfere with ordinary river navigation. Because we built no dams, we're not interfering with fishing. And because we built no dams, we're not flooding farmland. Some of the greatest environmental and financial disasters worldwide have come from misguided dam projects. In some cases, depending upon the terrain and upon the characteristics of the river, we wouldn't even use a barge. We would mount the generator equipment on the shore. So river power and wind power both represent very large potential sources of clean and cheap electricity. Two different designs of the LRP help harness this natural renewable energy that normally would go to waste. In fact, adaptations of these designs can tap into the ocean currents that flow ceaselessly in areas such as the Gulf Stream or around certain land masses. But Triton Technologies has another design, again using the same basic principle, but of a very different construction. Triton itself is named after this machine, the Triton Ocean Power Generator. Whereas wind and rivers and ocean currents show more or less constant direction of flow, ocean waves have very different characteristics and require different technology if we want to convert ocean wave power into electricity. The ability to do so represents considerable financial and environmental impact. The power in the ocean waves is estimated to be dozens of times the total energy used by all our populations worldwide. And because wave energy is caused by wind, it is inexhaustible. A single meter of shoreline receives enough energy to produce between 10 and 100 kilowatts of electricity. This single meter would power a small village in many parts of the world. For centuries, people have dreamed of making use of this awesome power. The patent files are filled with weird and wonderful and complicated contraptions intended to do just that. But anything you put into the ocean will not last long unless it is very strong, like a rock, or very flexible, like seaweed. The Triton is flexible and has no internal moving parts. It is the movement of the seawater itself which generates the electricity in the Triton.